7.2 is basic operations with complex numbers. It's important to note that we want to express all complex numbers in terms of I before performing these basic operations. The chart that's on this first slide, it basically just kind of goes over kind of basic generic formulas of your complex numbers. Starting with addition, essentially you'll see that really what we're doing here is combining like terms. So if you look, we have a plus bi, which remember that's your rectangular form for a complex number. We have that plus c plus di. So really what we're doing, we're taking a and c. Remember that's the real part of the complex number. We're adding those two together. And then we're taking our imaginary parts, b and di, and we're adding, well, bi and di, and we're adding those together. So like let's say we had, if bi was like 4i and di was 5i, we'd have 4 plus 5, or 9i. Subtraction works the same. The only thing to be careful about with subtraction, that negative there in the middle, you're going to distribute that to the c and to the di. So just be careful with that. Multiplication, here we are going to FOIL, which we will go over an example of doing this. But basically, this is kind of the generic formula, but just remember that we're just foiling here. And then division is a little difficult. Well, not difficult, it's a little different. Basically, we're just multiplying the numerator and the denominator by the conjugate of the denominator. That's kind of like rationalizing the denominator, sort of. Remember the conjugate, you're just changing that, the sign in the middle. So instead of c plus di, you're multiplying everything by c minus di. What this does is gets rid of an imaginary number in the denominator. Like you see the denominator here has just c squared and d squared. So no imaginary numbers. So let's try some examples. Alright, our first example we're adding here. So we have 3 minus 2i plus negative 5 plus 7i. So we're combining like terms here. I'm going to kind of group them together. So what we're doing is 3 plus negative 5 plus negative 2i plus 7i. So the 3 plus negative 5, so that gives us negative 2, plus negative 2i plus 7i, which is positive 5i. Treat your I kind of like it's a variable in this case, like it's x. So if it was negative 2x plus 7x, that would become positive 5x. Now let's look at the subtraction one. We have 7 plus 9i minus the quantity 6 minus 4i. So let's kind of distribute that negative into both of those. So that gives us 7 plus 9i minus 6 plus 4i. So we're combining like terms here. So 7 minus 6 gives us 1. And then the 9i plus the 4i gives us 13i. And that's our final answer. And then that's adding and subtracting. Let's multiply. Now when we're multiplying, like I said, we're going to FOIL this. Well, actually, in this case, we're going to distribute in this one. The next one we FOIL. So let's take, first let's put everything into I terms. So 6 doesn't change, but that square root of 4i, or, well, square root of negative 4, sorry. Square root of 4 is 2, square root of negative 1 is I. So that's going to be 2i. And then the square root of negative 9, square root of 9 is 3, square root of 1, square root of negative 1 is I. So that becomes 3i. So we have 6 minus 2i times 3i. So now what we're going to do, we're going to go ahead and distribute this 3i to both the 6 and the negative 2i. So this is going to give us 18i 6i minus 6i squared. Well, what's I squared though? We know I squared is -1. You should know that. If not, remember this. This is important. So let's rewrite this as 18i minus, let's see, that's 6 times -1. So it's just 18i plus 6. But I don't like the way that's written. We always like the real part first. So rewrite this as 6 plus 18i. Final answer. Now let's go ahead and... Alright, for this next problem we're going to FOIL to multiply here. So we've got negative 9.4 times 2.5. It's negative 23.5. And then negative 9.4 times 1.5 gives us negative 14.1 I. And then negative 6.2 I times 2.5 is negative 15.5 I. And last but not least, we have negative 6.2 times 1.5. So this one gives us, this one's cool because it's negative 9.3, but they both have an I, so it's negative 9.3 I squared. So now, let's combine like terms. Let's work on the two I terms in the middle there. So negative 23.5. Let's see, we've got negative 14.1 minus 15.5. It gives us negative 29.6 I. Now, the negative 9.3 I squared is pretty cool. I squared, we know, is negative 1. So that negative 9.3 I squared, really, that's gone. The I squared is gone. And this becomes a plus sign. So now let's combine these last little two I-like terms. So negative 23.5 plus 9.3. So that gives us 14.2 negative minus 29.6 I. Alright, to divide complex numbers, what we're going to do is multiply by the conjugate of the denominator. So in our case, we're multiplying both the top and the bottom by 3 minus 4i. Remember, the conjugate, you change the sign of the imaginary part. So in our case, the imaginary part is that 4i there. So instead of plus 4i, it's minus 4i. So let's FOIL. So 7 times 3, that gives us 21. 7 times negative 4i, gives us negative 28i. Negative 2i times 3 gives us negative 6i. Negative 2i times negative 4i gives us plus 8i squared. So that's the top. On the bottom, let's see, we've got, let me change pen colors. 3 times 3, so 9. 3 times negative 4i, so minus 12i. 4i times 3 plus 12i. And then 4i times negative 4i minus 16i squared. So now let's simplify. So let's see, on the numerator, we can combine the 21 and the plus 8i squared. Because remember, 8i squared, that term right there is going to be minus 8. Because the I squared becomes negative 1, so that makes that plus 8 to minus 8. So 21 minus 8 13, and then 28i and 6i minus 34i on the top. Now the denominator is fun because the 12i's cancel, and then this negative 16i squared is just going to become positive 16, because remember I squared is negative 1, so negative 16 times negative 1 is positive 16. 9 plus 16, 25. That's your final answer. That's a 3. So let's do one more example. In this example, first thing we have to do is find the LCD so we can combine these fractions together. So the LCD, just multiply your denominators together. It's going to be I times 3 plus I. So that first fraction, we need to multiply by 3 plus I. Second fraction just needs the I. So 2I over I, 3 plus I. Alright, so the denominator is just going to be I times 3 plus I. The numerator is going to be 3 plus I plus 2I. So this becomes 3 plus 3I over 3I, I'm distributing here on the bottom, plus I squared. So 3 plus 3I on the top, over, I squared becomes negative 1, put that in front, plus 3I. The reason we write that negative 1 term first, it's the real part. The real part goes first, the imaginary part goes second. So now we need to multiply by the conjugate. So I'm going to rewrite this down here. 3 plus 3I over negative 1 plus 3I. Conjugate, we're just changing that plus on the denominator to a minus. So we're multiplying this by 3, or not 3. We're multiplying this by negative 1 minus 3I over negative 1 minus 3I. And now we distribute. Alright, here we're going to go ahead and FOIL the top. So that's going to become negative 3 minus 9I minus 3I minus 9I squared. Now, when we distribute, or when we FOIL the bottom, we only need to worry about the first two terms there, so that's going to be positive 1, and then the last two terms, because we know the inside two cancel out. So now let's simplify on the top. So we have negative 3 here, and this negative 9I squared. I squared is negative 1, so that becomes negative 9 times negative 1. So that term becomes positive 9. So negative 3 plus positive 9, that gives us 6. And then our middle two terms, change colors, our negative 9i and our negative 3i becomes negative 12i. On our denominator, that minus negative 9i squared, I squared is negative 1, negative 9 times negative 1, that becomes a plus 9 as well. So then our denominator we have 1 plus 9, so this gives us 6 minus 12i over 10, but we can go one step further, we can reduce everything by 2, so that our final answer is going to be 3 minus 6i over 5.